I think I'll.
All right. Let's. So hopefully that was okay.
I think it's just the amount of time we have to do it.
I don't know. I have your other quiz. Someone remind me. I always forget to give the quiz. Someone remind me to give the quiz you took last week back. Which reminds me again. Okay. So now, one mistake I saw in the quiz that really stuck out, not because it was a difficult mistake, but on quiz 1, no, quiz 2, which was the one you took last week, or one of those quizzes, there was a problem like this, I believe. Now what was that?
3 plus 3 times 8 minus 3.
No.
A squared minus 2ab plus b squared. Isn't it a squared plus 2ab
A squared
minus 2ab
minus
2ab
2ab
plus b squared?
plus b squared. Now, so now I remembered about last quiz. One, which made me remember this. There were still people who did this and wrote that as the answer. Now, what was that?
What's the difference?
Like that was their answer. Like they didn't write this. They wrote this. You know what that meant they did?
It's where the
They distributed the power across sums. Now, there were a list of things on day 1 that I told you that you should never do. Now, this happened several times, more than a handful of times. And it's written in the syllabus, it's in bold, never do this, no matter what. Okay? And I took the time to go through examples and to talk about, okay, this means this times itself, and you can expand it, blah, blah, blah. And last week, people were still making this mistake. Okay, now, this is what I want to talk to you about now is not necessarily about math for a second. I just want to just have a real talk with you now, for like a general talk. Because I don't know, some of you are probably still freshmen. You haven't been in school that long, and so it takes some use to getting to the environment. What do I want to say? You know how some people are like, you'd have people out there talking about, formal education, it's not important, and they should teach you how to make money and file your taxes and stuff like that, and they talk about all that, and they're like, the quadratic formula, I've never used it a day in my life, I never had to use the area of a parallelogram in my life ever, they just teach me this in math class and blah, 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 blah. Okay, so you might hear things like that, and you might hear people say that education is not important and all that stuff. And I'm going to tell you now, it's because those people who say these things don't pay attention. Okay? One of the reasons why math is a nice, good thing to learn is that it teaches you to recognize patterns, to recognize things in their form. And when you're studying math, that's not just about the math. You can really apply this to anything. So, for example, being in school is not just literally about learning formulas. There's a social component to it. You're not here in a vacuum. You're not here by yourself. You have classmates. You have a teacher, right? There's a certain relationship, right? There's a certain, in some context, I have authority over you, for example, right? So, it's not just about learning the math, but it's about learning how to get along with your peers, how to get along with superiors, and all that stuff, right? So now let's say you go on a job, and you have a supervisor. And the first day the supervisor tells you, you know what I absolutely hate, man? And if people do this, I just fire them right away, right? And he goes through and he explains to you all this stuff that he's like, you know what, I hate this. Right? Now, whether or not that guy is irrational or he has a reason to hate that thing almost doesn't matter, right? If you want to keep your job, what should you do? Literally don't do the one thing this guy went off on a rant telling you he doesn't like you doing it. Right? It's not about multiplying this out. It's not about whether or not it's actually an important skill. It's about Jhevon went on a rant, put it in writing, put it in bold, called it a blasphemy, which is very strong language, took time on the first day of class to explain to you why you shouldn't do this. And several times in several classes after that, he literally tried to trick you to do it and then said, yo, yeah, you would never do that, because if you do that, Jhevon will kill you, right? And yet you go on the quiz and you do that thing. At some point, it's not about math anymore. It's not a math problem. That's not a math problem, right? So you getting that wrong, it's not a math problem. Because it's literally, no matter what you wrote here, this is quite literally the worst thing you could. You could have wrote, Jesus saves, and that would have been better. It's not about math problem. You write that, I wouldn't have been as upset. Write whatever else here except this. Because that is one of the mistakes I said you shouldn't make. Let me throw something out at you here. How would you look at, what if I told you to factor this? What would you say? If that showed up on a quiz and asked you to factor that, what would you do? Huh? Yeah?
I would do the I think it's perfect squares or something like that.
Okay.
So I would do 2x to the third power. Wait, actually no. Okay, wait, hold on. Yeah, 2x to the third power. Y. Z. This gets tricky. Alright, let me just skip that part. Minus.
Well, we're skipping it?
Yeah, we're gonna skip.
We're gonna come back to this part. Okay, all right. Minus?
Minus 3. You know what? You could choose somebody else. I thought.
You volunteered. I didn't pick on you. I didn't force anything out of you. Okay, who can help her out? Who can finish up this part? Yeah?
Is it square root z?
This is 2/3 here.
Yeah. So you're gonna change it. You're gonna change it.
To
So
what?
it's gonna be third.
You think of this as the cube root
Yeah.
of z squared?
Yeah.
Okay, how does that help? Maybe I can make it a little bit more obvious. So if I put a squared here.
Oh, okay.
Does that hint to what you should be
Alright,
doing?
so I think it's z to the 1/3 power
Okay.
minus 3a y to the second power plus 6. Not plus t to the 6th power. And then you put that in parentheses, the first section. No, like separately.
Oh, okay. Like this? Yeah.
Yes, and then you square both parentheses.
Okay.
That's your answer.
No, the question is the factor.
Oh, is it? That's not a factor.
No? Remember what factor means? To write it as a multiplication. You still have a sum of terms here. Yeah? You're gonna jump in? Yeah?
I'm not sure, would you do factor out the y squared?
Yeah, you can factor out the y squared. In fact, we can still do it here. I could factor out a y squared from here, and then I'd be left with this and that. Okay, and then what? You guys did most of the work already. The heavy lifting is done. How do you finish it? Who wants to try? How do you finish it? Yeah?
So you take term A, which would be 2, well, I'm trying to factor the inside of
Okay, tell me what to write next.
So, 2x third, z, b, 1 third, in parentheses, what's the other?
Well, we have y squared. That was
Yeah.
stuff. Yeah, and now you have?
And then you open the bracket, and then a parenthesis, 2x third, z 1 third, z 1 third, minus 3a,
That
I
thing?
3 6 to the 6. And then will be the same but plus. Yeah, parentheses.
Plus here?
Yeah.
Yeah. Now, the question is, did that look complicated to anyone when I just wrote this down?
Yeah.
It did? Why?
Probably because of the amount of letters and different exponents.
Right, the amount of letters, different exponents. Okay. So, when you told me to do this, what did you see?
Perfect squares.
Huh?
Perfect squares.
Well, it's not perfect square, difference of squares.
Yeah, difference of squares. Yeah.
Difference of squares. In other words, some people, the uninitiated, the people who have trouble on math tests, look at that and they see, oh, that's a bunch of letters, that's a bunch of numbers, super complicated, okay? The people who do better, when they see that, they really see this. Okay? Some people look at that, oh, there's a lot going on there. There's not a lot going on. There are two things with a minus sign in the middle, and all the powers are even. It's a difference of squares. Okay? Recognizing that those patterns, these forms and everything, that is what gets you through a class like this. That's what gets you through all of calculus. This is, I don't know what to call it, recognizing forms, I guess. It's a very important skill. It is the skill that deals with algebra. Right? The secret to being good at algebra. This is one of them. It's really two skills you need to be good at algebra, calculus, calc 2, calc 3. This is one of them. Being able to recognize a form, recognize a pattern, right? Understand that something complicated is really just something simple in disguise. You're always trying to look for the easy way out, the shortcut. What can I link this to? Something that I know. And which is one of the reasons why I emphasize these formulas to you, right? You know that that just becomes the first thing minus the second thing times the first thing plus the second thing, which is how we got to here. Okay? So once you realize there are two things, there's a minus sign in the middle, that should immediately make you think of this thing, right? And we'll talk about this when we're factoring later on, right? So you can see a certain form, right? And once you see that form, the process should be kind of easy because now you're not seeing all these complications. You really see something that's an A and you see something that's a B. Right? Like in the formula. This A and this B can be anything. Okay? So, and now to bring it back, the idea is some things might look different, but they're really kind of the same. In the same way, to a lot of people, this will be like being in school, this will be like being in the real world, but the truth is, they're the same. Right? One of the reasons why, you should come to class every day and all that, it's not just to study the material, that's important, don't get me wrong. You need to prove you know the material. But you should also be studying me. You should be studying your classmates, you should be studying your environment, you should be paying attention, you should be learning about norms and things like that. Because that will save you so much trouble, so much heartache. There's so many, getting this down and just applying it to everything else, because that's one of the usefulness of math. It's not about remembering the quadratic formula. That's not the point. The point is being able to look at your environment, look at the people you're interacting with, look at things that are going on around you, and then to distill from them their essential components, match it up to something simple, and then make decisions based on that, right? Once you see this for what it is, the decisions become easier. It's not a complicated thing anymore. And so, that's important, and also the mistakes you make. There are some mistakes that you shouldn't make for that reason, right? Because again, you need to be paying attention to everything. One example that I could point to, not far removed from academics, it's more closer, just so you can kind of see. But hopefully with me giving you this example, you'll see how to apply things in your life as well. When I was a freshman, I was an international student, so for me, getting good grades was important, because if I got a bad grade, I could literally get sent out of the country, right? Just if your GPA drops below a certain thing, you get out of the country. Okay. So I had this, I took that way overboard. I thought, oh, I have to get A's and everything or else I'm dying. That's not true. By the way, anyone who freaks out about their GPA, it's not a good way to look at things. But I was young. At the time, that's how I looked at things. I had to get an A and everything or else I'm gonna die and my life is over. Okay. I had a teacher who, and it was some writing, some creative writing where you had to do research papers. What they were writing for. It wasn't at this college, so I don't remember what it would match up to here. But yeah, I got my first paper there. I got like a B or something like that. I'm like, I was totally freaked out. And then I went to her and I talked about it. I'm like, I think the paper was good. I don't see why I got a B. I gave you everything you asked for. Blah 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 blah. And she was like, yeah. She she pointed out a lot of things that were wrong with my paper, and then she basically said, to paraphrase, oh, I'm a very tough grader, and basically I don't give people A's. It's very hard to get an A in my class, blah, 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 blah. So she gave me that speech, like, yeah, no matter how hard you try, I'm not going to get an A. It was like that, right? Now, this wasn't a math class, so it wasn't like she could ask 1 plus 1, and I said the answer is 2, and there's nothing she could say to me, because 1 plus 1 is 2. This was a creative writing class. It seems subjective, right? Writing is subjective. Like, how can I get this lady to like my writing? So the thing is, I knew I was a math major the first time I got into college. I immediately knew I wanted to study math. So a lot of people look at that and kind of like, oh, damn, okay, all right, maybe I'll just take a B in this because I worked really hard on this paper, what am I going to do? Instead, I decided to look at it a different way. Sure, writing is subjective in general, but to a particular person, it's not. There are going to be phrases that this person likes. There's going to be a way that she likes a research paper to be done, right? In her mind, there is a vision of a perfect research paper. Maybe it's 6 paragraphs, 4 sentences per paragraph, whatever. There's a list of rules in her head that no student has been able to figure out, right? So I didn't look at it as a situation where, oh, I don't, woe is me kind of thing. I looked at her as if she was a math problem. And all I needed to do to get that A is figure out what are the rules. So what I did was I started, going in textbook, writing out some essays and stuff like that, and I kept going to her, bothering her during her office hours, just like, okay, here I wrote this paper, I wrote this little page right here, critique it for me, right? And she'll say things like, oh, I wouldn't use this word here. What word would you use? Oh, I didn't like this. I think it would be nicer if you said it this way. What way? What way? Okay. Right? Bothered her. After a while, she was kind of annoyed to see me, but I didn't care. I needed to figure out the rules. Once I was confident, okay, she likes this, she likes this, she likes this, she likes this, she doesn't like this, she doesn't like this, she doesn't like this, she doesn't like this. Her idea of a paper looks like this. So in all my future papers in that class, what did I do? I did everything she likes. I didn't do anything she didn't like. And I made sure all my papers fit a certain format. And I got an A at the end of the semester. Now, I didn't get an A because I was smart. I want to make that clear. I got an A because I thought abstractly, and I was like, there are just some rules here, and she's a human being. Let me find out what she thinks a good paper is, and do that. Okay? So that needs to be a lesson to you. That will help you in math. Like, that's what math is about. But it's bigger than that, right? It's not always the smartest person who gets the better grade. It's not the person who worries about their GPA that gets the better grade. It's not the person who freaks out, studies all night, gets tired, and just runs on coffee that gets the better grade, right? The people who pay attention to their environment, pay attention to the professors, pay attention to the students, you have to pay attention. It's one of the things. Once you pay attention, you figure out the rules. And you just follow the rules. Right? And I don't mean rules like literally rules and laws. I mean like rules in interacting with certain people. Certain people like this, certain people don't like that. And that's really kind of taking the abstractness that we're learning here to the extreme, but it's an important thing. And if you're not doing so hot in this class, sometimes it's not just the math that's the problem. It's just your entire outlook, the fact of what you think is important versus not important. Distributing powers across sums, canceling cross sums, division by zero. Never do it. It's that simple. It doesn't matter even if it's important to math or not. The person giving you a grade thinks it's important. Right? Therefore, it should be important to you. That's all there is. It's not a math problem. Okay. Let's continue. So we were in 1.3. We started talking about factoring. We covered two things so far. I believe we covered GCF factoring. And we covered factor by grouping. That's that. I'll give you a general approach to factoring later, but for now, let's just look at some of the pieces. The third thing I want to talk about is factoring trinomials. That is the next thing I want to talk about. Yes. Factoring trinomials. Specifically of the form of things that look like quadratic. Now there are two cases. Okay, so we're going to do that now. There are two main cases. One, you can break these up into rules based on whether the first thing in front of the square term is a 1 versus if it's not equal to 1. These will be two different scenarios. In general, these ones are more complicated, but we'll go through the rules for each. So let's deal with the first case, a equals 1. So here's how we figure out how to do these. What you can note is that if you had something that looks like x plus a, x plus b, well, this is a different d. Maybe I should put different letters altogether. It's not going to matter. Okay, let's put d and e. Okay, so that's your x. Now, if you expand that, what would that look like?
X squared.
Plus x
plus
Plus xe
plus xe, yeah,
plus xd.
plus xd plus de, right? Now the middle terms we can kind of combine like terms here. So we have d plus e times x, right? And so we realize that if your a equals 1, it turns out that you can factor something to this. So what we did was expand. And remember what expanding is. It's the opposite of factoring. So to go this way, what we did was to expand. So basically to figure out how to factor, we just need to go the other way. And that's going to tell us what the rules are. Right? Factoring would be going that way. And so here's the pattern that we can notice now. Notice that the middle term is a sum of d and e, while the last term is a product. Right, so when we're figuring out what are the rules that will help me factor an expression like this, well, basically, start in a case where we expand, figure out how to reverse it. We'll know that the middle term is a sum of two numbers, these two numbers that would have factored in, and the last term is a product of two numbers, these two numbers were factored. So, so this tells us if a equals 1, we need to find two numbers that sum to give the middle term and multiply to give the last term. So that's how we figured out the rules for factoring those. So we can jump straight into an example here. And again, I know most of you would have seen this already, but we really want to start paying more attention, probably more than we ever have now. So we can get through these pretty quickly. There might be some people for whom it's been a while. So you would notice here in all of these, now you won't see it, but there's of course a 1 in front of the x here. So these will all fall under this pattern. So that's 5x plus 6. And so based on this pattern, I know that this should be able to factor looking like this, where there's an x in front, and now I need to find two numbers that they will add up and give me the middle term, they will multiply and give me the last term. What are the two numbers?
6 and negative 1.
Huh?
6 and negative 1.
If we choose 6 and negative 1, these guys add to give you positive 5, but if you multiply them, you get negative 6, so that doesn't work.
3 and 2.
Yeah.
3 and 2. Positive 3 and positive 2. Right? So here, so you'll note that 3 plus 2 equals 5, which is the middle. And 3 times 2 equals 6, which is the last term. And that's how you choose the numbers. So you see that? There's a 1 here. Normally you'll assume something factors. If it doesn't work out, it just doesn't work out. So here you'd start off with an x and an x. And what would be two numbers? When I add them I get positive 2. And when I multiply them, I get positive 1.
Plus 1 and plus 1.
Plus 1 and plus 1 are the two numbers. It is possible to repeat. Right, and this is called a perfect square, by the way. Right, that's what's a perfect square. It doesn't mean there are two squares. It means that you have a binomial or a whole sum all squared. So that's called a perfect square. And there are other patterns you could notice with perfect squares. But I think once you know this rule, you don't need to worry about it, actually, if you think of it this way. What about C? How does that work? How do we do that? Yeah?
Maybe you can group it.
Group it how?
I would say like take out the x and parentheses I'll put x. X plus. Actually, no, forget it.
Yeah, that's not going to work. I'll tell you something here. Notice there's a symmetry in x and y. Notice that here I have an x squared and x and something without an x, right? I also have a y squared, a y, something without a y. So there's a symmetry here. I can kind of think of it as a trinomial in either the x or the y variable. Whenever you see something that's symmetric in that way, the trick is you can actually ignore one of the variables in the beginning. And then put the variable back at the end. So if I ignored the, say the y, what would this look like if I ignored the y?
X squared plus x minus 12.
It would look like x squared plus x minus 12. Now how would that factor based on what we've done?
X plus 4, x minus 3.
X plus 4, x minus 3. And so that tells you the factoring of this one. It's going to be x plus 4, x minus 3, and you just put the y back. Y here, and y here, and that would be the factor. Something like that shows up every now and then. But that's basically the idea. Whenever you have 3 terms, and the coefficient of one of the square terms is 1, you try to find 2 numbers, and again you can think of these. If I multiply these, notice that I get the last one, and if I add them, I get the middle term. Okay, so that's kind of the easier case. If a is not 1, then things get a little bit more complicated. So let's deal with that second case. And so here, there are 2 methods. One, there's a way that you can do this with trial and error. And I'll explain that. It's my preferred method if you know it, but that's not a hard recommendation, and if you don't like it, just don't do it. The other one is a way that a lot of people know. It's called the AC method. We're going to do both. So I'm going to show you how to do it with trial and error, and how to do with AC. Okay. So this is in general when your A is not 1. And again, if we want to have an idea of how to do this, let's do it with the trial and error. Let's just expand something like dx plus e so this would be dfx squared plus ef plus dgx plus eg. Okay. So now, what does that tell us? Here's what that tells us about how to remove that. Maybe I should try it. dx plus e fx plus g. Let's look at the middle term, for example. I want you to realize that if you take these two, and then you add these two, that's how you would get the middle term. Do you notice that? Right? The product of the close ones and the product of the far ones added together would actually give you the middle term. Now, the ones at the end, the two last numbers, should multiply to give you the last term. And then, I got all these colored chalks, I'm going to use it. Okay. The two first ones give you the first term. So that's going to be the pattern. Notice that a random guy like this, where we're assuming this is not 1. That factors into something where the product of the first two should give you the first number, the product of the last two should give you the last number, and to figure out the middle, we just make sure that the inner number is multiplied plus the outer number is multiplied, give us the middle. Let's actually see that in action. So now, it's going to be a little bit of trial and error again, but in this case, the middle term is kind of going to be slightly annoying to figure out. You're just going to have to find an arrangement of numbers that gives you that. Now, at first, it's going to be, especially if you're not used to doing this, it will be a little bit annoying to get the hang of it, but I promise, the more you practice, the better you'll get at it, and if you practice a lot, you'll get quicker at it even than the AC method. You'll be able to see things very quickly after a while. There's another story about that, but I already took up a lot of time telling another story, so that's actually... That one was way back with little Jhevon, 9-year-old Jhevon. Okay, let's move on here. So let's use this. Examples. Let's say we have 2x squared plus, and of course we want to factor these. Okay, so now we're going to do a little bit of trial and error. I'm going to show you how to actually look at these. And in working through these, might make a few mistakes on purpose just so you can see what would happen if you made a mistake and how to actually recoup from that. But of course, the more you do it, the less mistakes you'll make in general. So let's call this A, B, C. A. Sometimes the numbers are easy because they're prime, and that really tells you, that really helps you out a lot. Because we know that the product of the first two must give you the first number. Now in this case, the first number is 2. Right? Now how many numbers do we know, how many whole numbers do we know that multiply together to give you 2? it has to be 1 and 2. That's literally the only choice you would think about, right? So here, it has to be just 1 and 2 are the only options, right? It's not always the case, but in this case, that's easy. Similarly here, 1 and 2 are the only options, right? So I know that this has to factor in this way. One of them has to have a 2x, the other one has to have a 1x. That has to be the case. Now I know from the last term, these two must multiply to give me this guy. In other words, I need these two should multiply to give 2. So let's see, so I know I have to put a 1 here and a 2 there, or I have to put a 2 here and a 1 here, right? So let's go some trial and error. Let's say we're going to do it wrong first so you can actually see what happened. So let's say I mistakenly put the 2 here and the 1 here. Okay? Now that's the wrong thing, but I want you to see why it's the wrong thing. Do you see why it's the wrong thing? Because now if I multiply these two, I get what?
2x.
I get 2x. If I multiply these two, I get what?
2x.
2x. And now you ask yourself, can I get a 5x from a 2x and a 2x? The answer would be no. Can't get 5. Right? Can't get 5. Right? No matter how I add them or subtract them or whatever, that's not going to get me to 5. Right? So that's one way in which you know that putting the 2 and the 1 in those locations wouldn't work. Another way you know it wouldn't work, also, so this is a mistake. I'm just explaining the mistake here. Also, you should notice that you've created a common term in the first parenthesis. Do you notice that? Two is in both things here, which means I could have factored out a 2, which means there should be a 2 in the beginning here, which means that should have been able to happen from the very beginning, right? Because it should be a 2 multiplying out everything. So that 2, if a common 2 is here, a common 2 should have been here, but that's a 5. There is no common 2. Right? So there are a couple of reasons that will hint to you that that's not how I want to set up the numbers. Now we can do the correct way. So if you have 2x squared plus 5x plus 2, you're pretty confident on the first two because that has to be a 2x and an x. You know there has to be a 2 and a 1. If you think 2 here, 1 here, you should immediately see that gives me a 2x and a 2x. That can't give me the 5. So I should put a 1 here and a 2 here. Now I do that quick check in my head. This one gives me 1x. This one gives me 4x. Then I ask myself, can I get to a 5x from a 1x and a 4x? The answer is yes. If I add these two together, that would give me 5. So I just need to make sure that both of these are positive. I need a plus 1x and a plus 4x added together. So that has to be a plus and a plus. And that would be the factors. So this would factor into 2x plus 1 times x plus 2. Let's try another one. This one is slightly more complicated. So again, I'm going to start breaking this up here. Now 6 is slightly more complicated because now I have a couple options. It could be a 1 and a 6 or a 3 and a 2, right? Now, you'll get used to this pattern eventually, but you'd realize that normally when the middle term is not that far away from the first term, you want to break it into its smaller pieces as opposed to one big piece and one small piece. because that big piece is going to get a big number in the middle term, right? So I guess there's a 3x and a 2x here, right? So that's kind of what my mind was on. And now I just realized that to get a 2, it has to be a 2 and a 1. So now I have to figure out how to put a 2 and a 1 here. Now if I put a 2 here, that's a common term of 2, so I probably wouldn't put the 2 there, I'd put the 1 here. And so the 2 has to be there. And so now I have to see, well, did I arrange them properly? This would give me 4x. This would give me 3x. Now, can I use a 4x and a 3x to get a 1x?
Yes.
Yes, if I take a plus 4 and a minus 3, that gets me to a 1x. So I want the 4 to be positive, so that's a plus sign. And I want the 3 to be negative, so that's a minus sign. And that's the factor. Okay, someone help me out with this one. What are you thinking? Who goes in the front? Huh? Who goes here?
5x and x.
5x and x, right? That's the only way to get a 5. 5 is prime, it has to be a 5 and a 1. Okay, what about the last terms? 1 and 3 are the only options there. Who goes where?
The 1 goes with the 5.
So you put a 1 here and a 3 here. This would give us 1x. This would give us 15x. Can I get to a minus 14 using those?
Yeah.
Yeah, just make this plus and that minus. That's going to give me a minus 14. So I want the 15 to be minus, right? So that's going to be a minus here. And I want the 1x to be plus. That's going to be a plus here. That's your factor. Okay, so that's trial and error. That's basically it. Right? So you make sure the first two numbers multiply to give you the first two. Make sure the last two numbers multiply to give you the last two. To figure out if that works, you have to do this kind of check to see if you can get the middle. If you can't get the middle, those are the wrong numbers. Maybe you have to rearrange things. But that's basically it. That's the trial and error. And practice that enough, you'll get used to it very quickly. I'm speaking from experience here. So eventually, everybody's going to be writing out the AC method, and you're like, in 2 seconds, you have your factor. So if you learn that, it's a very powerful way to factor something. You waste very little time. Okay, let's talk about the second way, the AC method. Okay, so it says the following: to factor, if possible. And again, it's possible for things to not factor. I think we all know. Sometimes the numbers just don't work out and you just wouldn't factor it. You'd have to do something else depending on the context. To factor ax squared plus bx plus c, 1, you'd find the number AC, right? So that's the first thing. That's why it's called the AC method. You're going to take A, you're going to multiply the C, and that's going to give you the number AC. 2. Now you're going to break up the AC. Find 2 numbers. Now, here's what you're going to want. You want them to multiply to give AC. They might not be A and C themselves, they might be 2 other numbers. And add to give the middle term. So it's a very similar thing to the when we had A equals 1. You just want to find 2 numbers that multiply to give you a certain thing, and they add to give you a certain thing. But in this case, they must multiply to give you AC. 3. You would split the middle term into these 2 numbers. And 4. finish off by factor by grouping. Because once you split the middle term, you've now created 4 terms, and factor by grouping will finish it off. So let's do some examples there. That's the AC method. It's a 4-step process. Did I have different examples here? Or did I want to? I have different examples, but you should try both methods. So try this method on the previous examples, but I have whole new examples for this. So, examples. Try the previous 3 on your own time. Other examples. We're going to factor this using the AC method. Last 2 are slightly more complicated, but as again, factoring you should be semi-familiar with, so I can start to throw in some weird things here. Hopefully it shouldn't be a problem. First one should be pretty straightforward. Let's say we have 12x squared plus 17x plus 6. Okay, we're going to do this using the AC method. So what does the AC method say we should do first?
Multiply and
Right. First find AC. That's going to be 12 times 6, which is what?
72.
That's 72. The next step says split 72 into 2 things. We need 2 numbers that multiply to give us 72, but they will add to give us 17.
9 and 8.
9 and 8. Yeah, that works. 9 and 8. So if I take a plus 9 and a plus 8, multiplying them will give me 72. Adding them will give me 17. So what you do now is you're going to split the middle term into those 2. So we're going to have 12x squared plus 9x plus 8x plus 6. And the good thing about the AC method is the order doesn't matter. So you don't have to worry. Should I put the 8 first or the 9 first? It's not going to matter. So don't worry about that, right? Once you split these, just put them down in any arrangement you feel like. Putting the 8 first, then the 9 second, it's going to work out. You will just get the factored in the opposite way, which multiplication is commutative anyway, it doesn't matter. Right, so don't worry about the order. Once you find 2 numbers multiplying to give you 72, adding to give you the middle term, split the middle term into those 2 numbers. And now what you're going to do is you're going to factor by grouping. So factor by grouping is something we looked at last time. So we should be okay here. So what would you do for the first one?
Factor out 3x.
Huh?
Factor out 3x.
3x is a common term. We'd be left with what?
4.
Plus 3.
Second one?
2. 4x, parentheses 4x plus 3.
Now remember, that's supposed to happen. You're supposed to have the same thing left over in parentheses. Because now that's your common term that you can factor out. And that's your factors. So that's called the AC method. Let's do this using the AC method. So here you would have AC equals what?
-6.
Minus 6. Split that.
-3 and +2.
Minus 3 plus 2. Multiply those, you get a -6. Add them, you get a -1. That works. So this means you have 2x to the 4th minus 3x squared plus 2x squared minus 3. Factor that by grouping. What's the common term here? Just x squared, right? So we'd have 2x squared minus 3 plus, here are 2x squared minus 3. That's our common term. Let's just factor that out. X squared minus 3 times x squared plus 1. What does this factor into?
It's not flexible.
Huh?
It's not flexible. You can't.
Yeah?
You can't.
You can't. It's a trick question. If it was a minus sign, you could.
Yeah.
With a plus sign, you can't. That's the answer. See. What did I have? 6 x plus y squared minus 11 x plus y plus 3. Oh, another thing. This is again a situation where you need pattern recognition, because you had to recognize that this actually looked like something squared plus something plus a constant, right? So the trick here is to realize that this was x squared squared minus x squared minus 3, that it's still a quadratic, right? It's just that the variable here is x squared instead of just an x, right? And that's what gave you the idea to actually do this method. Because this method works with quadratics only, but the idea is, I mean, technically it's not a quadratic, but in terms of a pattern, it's a quadratic. Similarly here, sure, oh, it's an x plus y, I don't know what to do. No, it's something squared plus the thing plus a term that doesn't have the thing. It's a quadratic. Right? Everything that has that pattern is a quadratic. I could put a 6 and a 3, still a quadratic, right? I could have put an 18 and a 9, still a quadratic in terms of your simplifications. And we'll probably talk about that more, but you tend to want to apply patterns globally first, and you worry about the details later. So when you look at this, don't worry about the fact that, oh, there's an x and a y. Look at it on the big scale, on the macro scale. What form does this look like? A quadratic. That's where you start. Worry about the x's and y's and the specific letters afterwards. When you get bogged down in the details too quickly, so that reminds me. And again, it's another life tip there. You know, for example, you have some people who are like, you know, they want to go to the gym, they want to start working out, getting healthy, and the questions they ask are like, oh, what supplement should I take? And you know, what's a macronutrient? Da, da, da. They start getting bogged down with the fine details of everything. It's like, yeah, you're never going to keep up that habit if you look at things that way. Look at the general spectrum, right? Try to go a few days a week, eat relatively healthy. Once you have that under control, then start worrying about the fine details. So, same thing with math. So in general, when you're looking at problems, these strategies, they help you not only the class, but you know, there are bigger strategies out there. So on the global scale, it's a quadratic. So I noticed that the coefficient of the square term is not 1, so AC method is what I'm going to try. If you didn't do the trial and error thing. AC would be what here? 18, that's the 6 times the 3. Break up 18 into two numbers that multiply to give you 18 but add to give you 11. So those multiply to give you positive 18. When you add them, you get negative 11. So what we're going to do is we're going to split the middle term. So this is going to be 6 x plus y squared minus 9 x plus y minus 2 x plus y plus 3. Now we're going to factor by grouping. What is the common term here?
X plus y.
There's another one.
3x
3x plus y is the common term. I have left over with what?
X plus y.
2x plus y.
2x plus y
Minus 9.
minus 3,
Minus 3.
because we took out a 3. Common term here. Well, just a negative sign. So 2x plus y minus 3. Now these are the same. So you can factor that out. So we have 2x plus y minus 3 times 3x plus y
Minus 1.
minus 1. And that's fine. I'd accept that as an answer. Some people might go a little bit further and just multiply this out to avoid the parentheses and time inside the parentheses. So that's what that would factor. So now, let me tell you about a general approach to factoring. I'll give you some examples to try out for next time, and I'll give you the quizzes back. Okay, factoring is going to be a super important thing. We'll be using it for the rest of the class, forever. And you'll be using it throughout calculus and all these classes. So now let's talk about a general approach to factoring. So eventually I'll just give you a bunch of random things and ask you to factor all these things, right? And you should just kind of know what should I look for first, what should I look for second, etc. So 1. Throw a random thing on a quiz or a test for you to factor. The first thing you're going to look for is look if there is a general common factor. If there is, factor that out first. And we looked at what that means. You factor it out, you factor out the common thing with the lowest powers, you subtract all those powers from what's inside. Okay, 2. Now, you'll kind of look for the special factoring cases. Now, we didn't do a lot of examples here. I'll throw in some more examples here. But you're kind of looking for the fact of if there are 2 terms, you should immediately try to look for if it's a difference of squares. Right, it's one of the first things we're going to look for. Maybe it might be a difference of cubes. It might also be a sum of cubes. There's no sum of square formula. Now there are a whole lot of other patterns that you can find here with 2 terms, but these are the ones you'd be responsible for. I'd ask you about these ones. I won't necessarily ask you about others. Okay. So if there are 2 terms, you try to see if one of these, does it look in form like a something squared minus something squared, right? And the individual things might look ugly, but you don't care. Can I write it as such there's something to an even power minus something else to an even power, right? That's difference of squares. And you can try the same thing with cubes. Okay? So first, is there a GCF? Is there 2 terms? If so, you should be thinking along these lines. 3. If 3 terms, right? So first look for the GCD. Then, if it has 2 terms, try one of those special formulas. If it has 3 terms, you do the thing that I just showed you. So try the trial and error method. Or AC method. If 4 or more terms, Try factor by grouping. Five. And this is kind of just a cleanup thing. Sometimes after you factored something using the first method that came to mind, you realize maybe the pieces can be factored even more. I think I put a problem on the quiz that was like this. I think it was like x cubed plus x squared minus 4x minus 4, something like that. That was on one version of the quiz. Right. So when written that way, it had 4 terms, right? There's no GCF, that's the first thing I would look for. Moving down, it doesn't have 2 terms, so skip over that. It doesn't have 3 terms, so skip over that. Boom, this is a guy with 4 terms. So the first thing I would look for here is factor by grouping, right? So that just randomly showed up. Immediately I'd think factor by grouping. It has 4 things in it. So in the first thing, it has common factor is x squared. You can get x plus 1. Second thing, common factor is minus 4. I get x plus 1. And I can factor, right? So that's the first step. But look here,
You gotta keep going.
you got to keep going. That applies difference of squares here. So this would be x plus 1, x minus 2, x plus 2. All right, which brings us to what the last step is. Check to see if any resulting factors can be factored further. As is the case here. And that's like a general approach. You know, I throw a bunch of random problems at you, say factor all these. You go through these steps, right? So learn these and learn the methods here. Well, we covered each of these methods. Here's some for you to try, and then we'll. These are mostly have to do with the 2, because we didn't do a lot of examples there. Factor minus x squared, 25x squared minus 36, x squared minus 16 over 25. 4x to the 6 minus 9y to the 4. X minus 2 squared minus 16. X squared minus 10x plus 25 minus 1 squared. X cubed plus 2x squared minus 9x minus 18. X squared plus 8. 8 cubed minus 1 over 27. X to the 6 minus y to the 6. So that ends 1.3. We'll do 1.4. And probably will also get to most 1.5 next time too. So we'll stop there. I will give you back quiz 2.